For the Master's exam, focus on the National Electrical Code 2002 edition. Since the state of Texas has not adopted the National Electrical Code 2005 edition, it is crucial to primarily focus on the National Electrical Code 2002 edition for the Master's exam. The exam will cover concepts and requirements from this code edition. Key areas to study include: firstly, general requirements and definitions; secondly, electrical installations; thirdly, grounding and bonding; fourthly, conductors, raceways, and cables; fifthly, overcurrent protection; sixthly, equipment for general use; seventhly, motors, motor circuits, and controllers; and eighthly, special occupancies and equipment. Additional considerations include: while the National Electrical Code 2005 edition has not been adopted, it is still recommended to review the major changes from the National Electrical Code 2002 edition to the National Electrical Code 2005 edition. This will help you understand the potential implications of these changes in the future. The Master's exam also tests knowledge of other codes and standards such as Underwriters Laboratories, American National Standards Institute, Institute of Electrical and Electronics Engineers, and Manufacturers' Instructions. Ensure familiarity with these sources. Practice using exam-style questions to familiarize yourself with the format and scope of the test. It is essential to focus studies on the National Electrical Code 2002 edition. By thoroughly understanding this code edition and its requirements, you will be well prepared for the exam and demonstrate your mastery of electrical safety and installation principles. Let's delve deeper into the specific areas of focus within the National Electrical Code 2002 edition. When considering general requirements and definitions, it is important to understand the scope and purpose of the National Electrical Code itself. The National Electrical Code serves as a comprehensive set of guidelines for the safe installation of electrical wiring and equipment. Become familiar with the definitions of key terms and phrases used throughout the code, as these definitions are crucial for proper interpretation and application of the requirements. Understanding the different types of electrical installations, such as residential, commercial, and industrial, is also important. Each type of installation has its own unique set of requirements and considerations. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, while bonding ensures that all metallic parts of an electrical system are at the same electrical potential. This helps to prevent electrical shock hazards. Study the requirements for grounding electrodes, grounding conductors, and bonding jumpers. Also, understand the different types of grounding systems, such as grounded and ungrounded systems. Conductors, raceways, and cables are the pathways for electrical current. Conductors are the wires that carry the current, while raceways and cables are the enclosures that protect the conductors. The National Electrical Code specifies the types of conductors, raceways, and cables that are permitted for different applications. It also specifies the ampacity of conductors, which is the amount of current that a conductor can safely carry. Overcurrent protection is designed to protect electrical circuits from overloads and short circuits. Overcurrent devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The National Electrical Code specifies the requirements for overcurrent protection, including the size and type of overcurrent devices that are required for different circuits. Equipment for general use includes a wide range of electrical equipment, such as lighting fixtures, receptacles, switches, and appliances. The National Electrical Code specifies the requirements for the installation and use of this equipment. These requirements are designed to ensure that the equipment is installed and used safely. Motors, motor circuits, and controllers are used to power a variety of equipment, such as pumps, fans, and compressors. The National Electrical Code specifies the requirements for the installation and control of motors and motor circuits. These requirements are designed to protect the motor from overloads and short circuits, and to ensure that the motor is properly controlled. Special occupancies and equipment include locations such as hazardous locations, healthcare facilities, and swimming pools. These locations have unique electrical safety requirements due to the increased risk of electrical shock or fire. The National Electrical Code specifies the additional requirements for these locations. While the National Electrical Code 2005 edition has not been adopted, reviewing the major changes from the National Electrical Code 2002 edition to the National Electrical Code 2005 edition is still beneficial. This will help you understand the direction of the electrical code and the potential implications of these changes in the future. The master's exam may also test knowledge of other codes and standards, such as Underwriters Laboratories, American National Standards Institute, Institute of Electrical and Electronics Engineers, and Manufacturers' Instructions. Underwriters Laboratories is a safety organization that tests and certifies electrical equipment. American National Standards Institute develops and publishes standards for a wide range of products and services. Institute of Electrical and Electronics Engineers is a professional organization for electrical and electronics engineers. Manufacturers' instructions provide important information about the installation and use of electrical equipment. Familiarity with these sources is essential for passing the master's exam. It is highly recommended to practice using exam-style questions to familiarize yourself with the format and scope of the test. This will help to build confidence and improve test-taking skills. There are many resources available for practicing exam-style questions, such as study guides and online practice tests. When preparing for the master's exam, remember to focus studies on the National Electrical Code 2002 edition. Thoroughly understanding this code edition and its requirements will prepare you well for the exam and demonstrate mastery of electrical safety and installation principles. To further clarify certain aspects, let's consider some more specific examples related to grounding and bonding, which is a frequently tested area. Firstly, grounding electrode systems. The National Electrical Code 2002 edition outlines acceptable grounding electrodes, including metal and groundwater pipes, concrete encased electrodes, also known as UFA grounds, ground rings, and rod and pipe electrodes. It's vital to understand the requirements for each, such as minimum size and installation depth. For instance, if using a ground rod, you need to know the minimum diameter, which depends on whether it's non-ferrous or iron or steel, and the minimum depth to which it must be driven into the ground, typically 8 feet or 2.44 meters. Secondly, bonding jumpers. Understand the purpose of bonding jumpers, which is to ensure electrical continuity and conductivity. Pay close attention to sizing requirements for main and equipment bonding jumpers, often determined by the size of the ungrounded conductors feeding the equipment. For example, Table 250.66 in the National Electrical Code 2002 edition is used to determine the size of grounding electrode conductors and bonding jumpers based on the size of the service entrance conductors. Thirdly, equipment grounding. Equipment grounding conductors, or EGs, provide a low impedance path for fault current back to the source. Know the acceptable types of equipment grounding conductors, such as wire, rigid metal conduit, and electrical metallic tubing. Be familiar with sizing EGC based on the rating of the overcurrent protective device in the circuit, as indicated in Table 250.122 of the National Electrical Code 2002 edition. Fourthly, separately derived systems. A separately derived system, such as a generator or transformer, requires its own grounding electrode system. Understand the requirements for grounding these systems, including the location of the grounding electrode connection and the sizing of the grounding electrode conductor. Section 250.30 of the National Electrical Code 2002 edition provides detailed guidelines for grounding separately derived alternating current systems. Moving on to conductors, raceways, and cables, here are some additional points to consider. Firstly, conductor ampacity. Understanding how to determine the ampacity or current carrying capacity of conductors is essential. The National Electrical Code 2002 edition provides tables such as Table 310.16, which lists the allowable ampacities of insulated conductors based on their insulation type, size, and temperature rating. Be aware of the correction factors for ambient temperature and the number of conductors in a raceway or cable, as these can significantly reduce the allowable ampacity. Secondly, raceway fill. The National Electrical Code specifies the maximum percentage of fill allowed in different types of raceways, such as conduit and tubing. Exceeding the allowable fill can make it difficult to pull conductors, damage the insulation, and reduce the heat dissipation capacity of the conductors. Table 1 of Chapter 9 in the National Electrical Code 2002 edition provides the percentage of cross-section of conduit and tubing for conductors. Thirdly, cable types. Be familiar with the different types of cables commonly used in electrical installations, such as non-metallic sheath cable or NM cable, armored cable or AC cable, and underground feeder and branch circuit cable or UF cable. Each type of cable has its own specific applications and installation requirements. For example, NM cable is typically used in dry locations, while UF cable is suitable for direct burial in the earth. Fourthly, conductor identification. The National Electrical Code requires that conductors be properly identified to indicate their function, such as grounded or neutral conductors, ungrounded or hot conductors, and equipment grounding conductors. Grounded conductors must be white or grey. Ungrounded conductors can be any color other than white, grey, or green, and equipment grounding conductors must be green or green with yellow stripes. Regarding overcurrent protection, the following details should be considered. Firstly, circuit breaker and fuse characteristics. Understand the operating characteristics of circuit breakers and fuses, including their interrupting rating, which is the maximum fault current that they can safely interrupt. Ensure that the overcurrent protective devices used in an electrical system have an interrupting rating sufficient to handle the available fault current at that location. Secondly, coordination. Overcurrent protection should be coordinated to minimize disruptions to the electrical system. Coordination means that the overcurrent devices closest to the fault should trip first, while the upstream devices remain closed to maintain power to other parts of the system. This can be achieved by selecting overcurrent devices with appropriate time current characteristics. Thirdly, ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect people from electrical shock by detecting ground faults and interrupting the circuit. The National Electrical Code requires GFCIs in specific locations, such as bathrooms, kitchens, and outdoor areas. Understand the requirements for GFCI protection and the different types of GFCIs available. Fourthly, arc fault circuit interrupters, or SIs. SIs are designed to protect against fires caused by arcing faults in electrical circuits. The National Electrical Code requires SIs in dwelling units to protect branch circuits supplying outlets in bedrooms, living rooms, and other areas. Regarding equipment for general use, remember these key points. Firstly, receptacle spacing. The National Electrical Code specifies the maximum spacing between receptacles in dwelling units to ensure that appliances can be used without the use of extension cords. General guidelines include that receptacles should be installed so that no point along the floor line is more than 6 feet from a receptacle. Secondly, lighting requirements. The National Electrical Code has requirements for the type and location of lighting fixtures in different areas. For example, lighting fixtures installed in damp or wet locations must be rated for those conditions. Also, the National Electrical Code specifies minimum lighting levels for certain areas, such as stairways and hallways. Thirdly, appliance installation. The National Electrical Code provides requirements for the installation of appliances, such as ranges, ovens, and water heaters. These requirements cover issues such as clearances, ventilation, and overcurrent protection. Fourthly, switch locations. The National Electrical Code specifies the requirements for the location of switches in different areas. For example, switches controlling lighting outlets and stairways must be located at each floor level. When focusing on motors, motor circuits, and controllers, be aware of these additional details. Firstly, motor overload protection. Motor overload protection is designed to protect motors from overheating due to excessive current draw. The National Electrical Code specifies the requirements for motor overload protection, including the size and type of overload devices that are required. Secondly, motor disconnecting means. The National Electrical Code requires a disconnecting means for each motor to allow it to be energized for maintenance or repair. The disconnecting means must be readily accessible and capable of being locked in the open position. Thirdly, motor control circuits. Motor control circuits are used to start, stop, and control motors. The National Electrical Code provides requirements for the wiring and protection of motor control circuits. Fourthly, variable frequency drives, or VFDs. VFD are used to control the speed of motors. The National Electrical Code has requirements for the installation and wiring of VFD. Lastly, special occupancies and equipment considerations. Firstly, hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dusts are present. The National Electrical Code has special requirements for electrical equipment installed in hazardous locations to prevent explosions and fires. Secondly, healthcare facilities. Healthcare facilities have special electrical safety requirements to protect patients and staff from electrical shock. The National Electrical Code specifies these requirements, including the use of isolated power systems and ground fault protection. Thirdly, swimming pools. Swimming pools have special electrical safety requirements to protect swimmers from electrical shock. The National Electrical Code specifies these requirements, including the use of ground fault circuit interrupters, or GFCIs, and bonding of metallic parts. Fourthly, agricultural buildings. Agricultural buildings, such as barns and poultry houses, have special electrical safety requirements due to the presence of moisture, dust, and corrosive materials. The National Electrical Code specifies these requirements. Thoroughly reviewing the National Electrical Code 2002 edition, including these specific areas, is crucial for success in the master's exam. Remember to practice applying the code requirements to real-world scenarios and exam-style questions to solidify your understanding.